This is a video of the quiz review warm-up for special derivative rules. Before you check any of your work, make sure you add these 2 additional questions to your practice. And at the top of your quiz, these will be the directions. So we're going to follow these directions as we do the review. Show your work, simplify completely. If a term has a greatest common factor, factor it out. Combine all like terms. If a problem starts with a negative exponent, you can leave the negative exponent in your answer. Every equation needs to have appropriate function notation. All right, so let's start with number 1. When you have a 5 to the 6x like this one, that is an a to the u rule. Here's our a to the u. So the derivative is ln a to the u prime. So the derivative here, y prime, this is our function notation for the derivative, is ln 5, that's the a, times 5 to the 6x times the derivative of the power is 6. This can be in any order since all 3 pieces are multiplied. Okay, we got another one in number 2. This is another exponential a to the u. So dy dx is another function notation for derivative. So the derivative is ln a times a to the u times u prime. All right, let's try 3. It now has an exponential base of e. So that's our e to the u rule, which has a derivative of e to the u times u prime. This is e to the u. All right, so there's the rule. The derivative is e to the u times u prime. This coefficient, it just would look nicer in the front, but this is technically correct. The problem started with the negative exponent, so I'm going to leave the negative exponent in the answer. All right, number 4. Yes. So now the derivative is e to the u times u prime. This 2x is the derivative of the power. Just going to slide that to the coefficient spot in the front. All right, for 5, now we have a coefficient on our e function. And that's okay, it's going to work the same way. The derivative is the coefficient carries to your answer. Just copy it to the derivative. And then we've got e to the u times u prime. And this is all multiplied. So the 3 and the 6, I can combine those coefficients. Then I've got e to the x to the 6 and x to the 5th. If it's bothering you that the 6 was then separated from the x to the 5th, you can think of it like this. All 4 pieces are part of the product and multiplied together, which is why we can combine the 3 and the 6. All right, number 6. Now we have an ln function. All right, ln, on our rules here, ln of the argument goes to 1 over the argument times u prime. this is the u. So the derivative is 1 over u times u prime. We're going to combine our like terms. 3x squared has a denominator of 1, so I can multiply numerators, multiply denominators, and that's it. Nothing factors, nothing simplifies. You can simplify nothing else here on the answer to number 6. Okay, number 7. In number 7, this is now a product rule because we have one function multiplied by the other function. So I'm going to set up my table. E to the x has a derivative of e to the x. ln u is 1 over u times u prime. Negative divided by negative is positive. So the derivative is ln negative x times e to the x plus e to the x times 1 over x. These terms share an e to the x that I can factor out. And that would be my final answer. When we're factoring, I'm envisioning these terms and rewriting my answer as a multiplication problem. All right, 7. Number 8. Note we got another product rule. So I individually need the derivatives. And so then the derivative is, so you have to remember your function notation. Multiply this way, plus multiply the other way. And that's all we can do there. Nothing factors. This is a binomial. I could distribute that, but it really won't get me anywhere. That's it, we're done. Okay, in number 9, we have a quotient. We have division of functions. So for the quotient rule, I need my pieces. I'm going to multiply this way. So the derivative is low d high minus high d low all over the denominator squared, or low low. You can leave your denominator when it's a binomial as that binomial squared. You do not have to multiply that out. I notice in the numerator, I can factor out an e to the x. This could be your final answer. The quadratic that remains here, I think it just would look a lot nicer if it was in standard form. And so this would be my final answer. All right, number 10. Another quotient rule. Low d high minus high d low all over low low. Okay, so when I set up my quotient rule, even though I'm multiplying the denominator times the numerator's derivative, it looks nicer with the coefficient in the front so that I can see to distribute. Even though I'm multiplying this direction, again, it looks nicer with the negative in the front so that I can envision both of those, the negative one being distributed. So that gives us 2x minus 10 minus 2x minus 1 for a final derivative of negative 11 divided by x minus 5 squared. All right, 2 more questions. These were the ones I added on. And when I look at number 11, I notice it's a compositions of functions. I have this polynomial function underneath the square root function. So that's a chain rule. For the chain rule, we do the derivative of the outside. And one derivative I have memorized is that the square root of x will have a derivative of 1 over 2 root x. It's just, put that on your note card, memorize it. It's just better, easier, faster than doing the power rule with the 1/2 power. So the outside function here is square root. So it's going to have a derivative of 1 over 2 root, and we leave the inside function alone, times, now it's the derivative of the inside. So I'm going to do the power rule, 4 times 6, subtract 1 from the exponent, 5 times 2. Then I'll make this together to one fraction. I've got numerator, denominator. Nothing else can simplify. That's your final derivative equation. No factoring in the numerator. That's it. Okay, and 12. Is another chain rule situation. We have this polynomial inside the 5th power with the coefficient. So our derivative is outside derivative, outside function, so 5 times 2, subtract 1 from the exponent, leave the inside alone. Don't touch the inside function yet. Then we're going to multiply by the derivative of the inside function, so 3x squared minus 2x plus 1 plus 0. I gave myself too much space. And that would be our final derivative. This 10 could technically multiply by this polynomial. I don't really think it adds any value to the final answer. This power of 4 blocks anything from the inside function, so don't change here. That's to a 4th power. So just one other option, the way this could look. There's my polynomial to the 4th, and then 10 times 3 times 2 times 1, so that would be 30 squared minus 20x plus 10. Either of these answers would be fine. If you're looking for additional practice, page 39 is another great warm-up to try again to prepare for the quiz.